Good morning, students. Today we can have a look on the Newton's second law of motion. We discussed the Newton's first law. Newton's first law says the summary is when F is equal to 0, the acceleration is also will be 0 or must be 0. So whenever net external force is 0, acceleration must be 0. If net external force is not 0, then what about the acceleration? Or if net external force is not 0, then the velocity remains constant or the velocity continues to be 0. If net external force is not 0, will the velocity changes? If velocity changes, there will be acceleration. So the acceleration, whether the body may accelerate it. If net external force is not 0, then the body may accelerate it. We can have an induction from the first law. So from the first law itself, we can have an induction towards the second law. Now, second law actually it gives the exact measurement of force, the exact measurement of applied force as well as the direction of force. So since force is a vector quantity, force is having the magnitude as well as the direction. So both magnitude and direction are defined in the second law. Since second law states the direction as well as the magnitude, so that is the comprehension of the force. The force is fully stated. The external force is fully stated by the second law. Hence, the second law is often called law of force. The second law is often called law of force since it gives the exact measurement of the force. Since it gives the measurement of force, the second law is also called law of force. Now we are just having the wording of the statement. First I will read it, then I will explain it. The rate of change of linear momentum of a body is directly proportional to applied force and change takes place in the direction of applied force. One more time. The rate of change of linear momentum of a body is directly proportional to applied force and change takes place in the direction of applied force. So here we are discussing the magnitude. The magnitude of the force. Here we are discussing the magnitude of the force. Here we are discussing about the direction of force. Here we are discussing about the direction of force. Now first we will split it in the two parts. First we will talk about the magnitude, or that is the strength of the force. Then later we will discuss about the direction of force. Now see, rate of change of linear momentum. Rate of change of linear momentum of a body is directly proportional to applied force. So the applied force can be regarded as the rate of change of linear momentum. The applied force can be regarded as the rate of change of linear momentum, or the rate of change of linear momentum is directly proportional to applied force. The rate of change of linear momentum is directly proportional to applied force. Yesterday we had the discussion over the change of linear momentum. Change of linear momentum we already discussed it. It is, if you are considering m is the mass and the u is the initial velocity and v is the final velocity, then it is nothing but m into v minus u. That is a change of the linear momentum. That is a change of the linear momentum if u and v are the velocities, initial and final velocities. Now rate of change, there is a particular word it is I have added here. Rate of change. What do you mean by the rate of change? If you are discussing the rate of change, then that part is over. See, rate of change is nothing but the time rate. Rate of change, or we can also say time rate. What do you mean by the time rate? Time rate is nothing but the change happens in unit time. Whatever change happens in unit time, that is the rate of change. Rate of change is nothing but whatever change happens in unit time. If a quantity is changed 50 units, if a quantity is changed 50 units in 10 seconds, then what would be the change happen in 1 second? Change happened in 1 second. The total change is 50 and the total time taken for it is 10. So then what will be the change happening in 1 second? The change happening in 1 second is 50 divided by 10. The change in quantity divided by change in time. The time taken is 10. Change in quantity is actually 50. So 50 by 10 is 5. So rate of change of that particular quantity is actually 5. Okay, getting it? So that is a rate of change. So here same way we can also relate the rate of change of linear momentum. Now the change of linear momentum in unit time, rate of change of linear momentum we can regard it as change of linear momentum in unit time or change of linear momentum per unit time. That is the rate of change of linear momentum. So that is actually proportional to the applied force. Now we are discussing the change takes place in the direction of applied force. So the rate of change of linear momentum we first found. Then the change of the linear momentum happens only in the direction of applied force. So that is the direction of the force. So by understanding the change in momentum is positive or negative, we can understand which direction the force is acted. If the force is acted, if we are getting the change in momentum is positive, then force is acted in the direction of velocity. If we are getting the change in momentum is negative, then actually the force is acted opposite to the direction of velocity, that we will discuss one more time. So the change takes place in the direction of applied force. So the change of momentum takes place. Change takes place means change of momentum takes place in the direction of applied force. So now we are going to relate the rate of change of linear momentum with the external force. Applied force meaning external unbalanced force. So first we are discussing the rate of change of linear momentum. See, let m be the mass, u be the initial velocity, v be the final velocity, and t be the time taken. There is a body of mass m was moving with the initial velocity u, and the velocity changed to v in a time interval of t. That is the meaning. Now we are finding the change in momentum, the entire change of the momentum. Change in momentum, Pf meaning final momentum, Pi meaning initial momentum. So change of momentum Pf minus Pi is equal to mv minus mu. Okay. So change of a quantity we will use the delta. This is called delta DLTA. Sorry. This delta is actually an alphabet from Greek letter. So delta denotes the change in quantity. So here what is the change in quantity? That is nothing but the momentum. So change in momentum, delta P denotes change in momentum. Change in momentum is equal to m into v minus u. See, what is the total change in the quantity? M into v minus u. What is the total time taken? That is t time has taken. Now we are finding the rate of change. Rate of change is nothing but change in the quantity divided by the time interval. Change in the quantity is m into v minus u, and time taken is t. So the rate of change of momentum is m into v minus u by t. Now on considering this part, v minus u by t from the Newton's kinematic equation, this is you already learned. This part is you already learned part. This one. That is nothing but v minus u by t is nothing but acceleration. So that is acceleration. So what is the rate of change of momentum? Rate of change of momentum is ma. That is simply we can write is a rate of change of momentum. So we discuss it up to here. Now we are connecting it with the applied force. The rate of change of momentum of a body is directly proportional to applied force. So now the second law says F is proportional to ma, or ma is proportional to F. So that we can remove the proportionality sign by multiplying with a constant. So we can write F is equal to Kma. F is equal to Kma. But here the constant, the value of the constant K is actually 1. So 1 into ma is nothing but ma. So F is equal to ma. So the second law is F is equal to ma. The second law is F is equal to ma. Now consider F is equal to ma. We are considering the force as constant. We applied a certain constant force to different masses. For example, first body and second body. The second body has mass twice of the first body. So second body is having mass twice of the first body. Then what about the acceleration? Which one will be accelerated more? If you are giving same force to a car and a cycle, which one will be moving? Which one will be accelerated more? The cycle will be accelerated more than that of car. So when mass increases, then for a given force, acceleration will be reduced. For a given force, if mass increases, acceleration will be reduced. For a given body or for a given mass, we are considering two car and we are applying two magnitudes of force. One is F and other is 2F. One car we are applying F force, another car we are applying twice of the first force, that is 2F force. Then which will be more accelerated more? The second car will be accelerated more. So if force is increased and mass remains constant, then acceleration will be increased. If force is doubled for a given mass, then acceleration will be doubled. If force is halved for a given body, then acceleration will also be halved. In order to accelerate double for a body, we have to give twice of the force. So many relations can be obtained from the equation F is equal to ma, and of course we have to discuss something over the unit. Now we are discussing the unit. See, m, unit of force. I hope you are able to see unit of force. Unit of force we are discussing F is equal to ma. So here see mass, unit of mass in SI unit or the CGS or the MKS unit, it is nothing but kg. And unit of acceleration is meter per second square. Meter per second square. So this is the unit of force in terms of base quantity, in terms of base unit, in terms of fundamental unit. The unit of force is kilogram meter per second square. Kilogram meter per second square. This kilogram meter per second square is also called Newton. So the other unit is Newton. Now see, kilogram meter per second square or Newton, which can also write with small letter Newton. So while writing in the small letter, we have to use all the letters are small letters, and if you are writing n alone, it should be capital N. There is certain rules regarding the writing of the unit. So according to that rule, if you are using n alone, we have to write in capital letter. If you are writing fully, we have to write fully in small letters. And for example, you can write 10 Newton force, or you can write 10 Newton. In either way you can write. Okay, so I hope you understood the concept. Thank you.